This video is the first of 2 videos on chemical bonding, and will cover ionic bonds. Now, ionic bonds are between a metal, which has a positive charge, and we call that a cation, and a nonmetal, specifically a nonmetal ion, that has a negative charge, and that is called an anion. It's a cation, positive charge, anion, negative charge. Now, looking at the periodic table, the easiest way to figure out what the charge on the atom is going to be is by looking what column of the periodic table that you find the atom in. Now, we're going to ignore this whole middle part of the table. So up here, these are the transition metals. Transition metals. We are only concerned with the columns to the left of those transition metals and the columns to the right. Down here, these are the lanthanides and the actinides. Not concerned about those either for what we are doing today. So by looking at the column, we can determine what the charge of the atom is going to be. All atoms want their outermost shell, which is called the valence shell. So the valence shell is the outermost electron shell. They want their valence shell to contain 8 electrons, to be a full valence shell. Now, the valence electrons, given it's the outermost shell, are also the electrons that are involved in chemical reactions. They're the ones involved in bonding. Column 1 here has 1 valence electron. Column 2 has 2 valence electrons. Column 3, 3, then 4, 5, 6, 7, and 8. So that's the number of valence electrons, and it corresponds to the column. Now, one thing I just noted here is that this periodic table incorrectly labels one of the groups. The gray here is not the alkaline earth metals. That's the light green. The gray here is the transition metals. Can't really see that, but it's the transition metals, not the alkaline earth metals. Column 2 is the alkaline earth metals. So that's a mislabeled periodic table there. But again, not a big deal. We're not dealing with the transition metals, but just to not confuse you. So now we've defined the number of valence electrons in each of these columns. In ionic bonds, the metals lose electrons to become cations, get a positive charge. In column 1, they lose 1 electron, so they'd have a +1 charge. In column 2, they lose 2 electrons, so they'd have a +2 charge. Column 3, they'd have a +3 charge. Now, column 4, these atoms generally don't form ionic bonds. They form what are called covalent bonds, which we'll look at in the next video. Column 5, again, forms a lot of covalent bonds, but there are some ionic bonds that these elements will form. So because they have 5 electrons in the valence shell, it's easier for them to lose it's easier for them to gain 3 electrons than it is for them to lose 5 electrons. So because of that, they'll take on 3 electrons and they'll get a -3 charge. Now this column, because it has 6, it'll gain 2 to get a -2. And column 7 will gain 1 and get a -1 charge. Now column 8, those are the noble gases. They already have a full outer shell, so they don't have to bond to achieve that. So they are very unreactive. All right, now how exactly does this form? I'll use sodium fluoride as the example. So we have sodium and fluoride. Or technically here sodium and fluorine, and it'll become fluoride. Rather than drawing all the protons and the neutrons, I'll just label that as sodium. The first shell has 2 electrons in it, right? Because the first shell can only hold 2 electrons. The second shell here has 8 electrons. And then the third shell, the valence shell, has 1 electron. Together that's 11 electrons, and sodium's atomic number 11. So 11 protons, 11 electrons, atomic number 11. Fluorine, the first shell. I'll use a different color for these electrons. It has 2 in the first shell, and it has 7 in the second shell. 7 in the second shell. That together adds up to 9, which is the atomic number of fluorine. So 9 protons, 9 electrons. What happens here is this electron leaves sodium and goes over to fluorine. So now we have 2 electrons, and then we have a full shell of 8 electrons here. And this atom is now an ion with a +1 charge, because it still has 11 protons, but now it only has 10 electrons, because it lost an electron. Fluorine, on the other hand, gained 1. So you still have, make sure you keep the colors consistent. Still have 2 in the first shell, but now you have 8 in the second shell. You had 7 to begin with, and then you gained 1 electron from sodium. So now, if you count up, that's 10 electrons for fluorine, but it only has 9 protons. So that means the fluorine overall is now fluoride, because it's an ion with a -1 charge. And if you remember, positive charges and negative charges attract each other. And that's now what forms our ionic bond, the attraction between the positive cation and the negative anion. So be sure to check out the second video in the chemical bonding, which will be on covalent bonds. See you then.